This is Mrs. Naslin, and today we'll be doing Unit 11, Lesson 5, Compare Decimal Numbers to the Thousandths. Our learning targets for today are, I can find and identify equivalent decimal numbers, such as 2/10ths and 2/100ths. Our second learning target is, I can identify the greater or less of two decimal numbers. So first, I want us to take a look at this page. And I want to decide, these are whole numbers, and I want to decide if we could add a 0, where would we add it so that we don't change the value of the number? So for example, I look at 63. If I add a 0 behind the number, it would become 630, so that wouldn't work. But could I add a 0 in front of the number? Is it still 63? Yeah, it is. How about this one, 630? If I add it behind here, it would become 6,300. But if I add a 0 in front of it, guess what? It's still 630. And that applies for all of these whole numbers. If I add numbers behind any of these whole numbers, it changes the value. But if I add it in front, it does not change the value. Let's look at decimals though. Decimals are kind of the opposite. So I look here, and if I want to decide where can I place the decimal without changing the value. Or sorry, place the 0 without changing the value. If I add a 0 right here, okay, so in front of the number in this case is going to go right before the decimal place. So if I add a 0 right here, instead of me having 40 hundredths, I would have 40 thousandths. But if I add a 0 here, instead of having 40 tenths, I'd have 400, or I would have, instead of having, 40 hundredths, I would have 400 thousandths. But really, it's the same number. In decimals, we can add numbers, the zeros, behind the number, and it doesn't change the value of the number. It might look different, but the value of the number doesn't change. Just like when we did whole numbers and we add zeros before of it, it looks different, but the value doesn't change. So let's dig into that deeper. Let's look at these list of numbers and let's do a comparison. The first question says, what happens if we insert a 0 to the right of a whole number? So I look here and I add a 0 to the right of the whole number. So if I add a 0 on here, I get 30, and another one, I get 300. It changes the value of the number, right? Anytime I add a 0 behind a whole number, it changes the value. Instead of having 52, I have 520, and then I have 5,200. So it changes the value of the money, okay? Or of the number. Now, what happens if we insert a 0 to the right of the decimal? So if I look here and I do the same thing and put the 0 to the right of the number on a decimal, I have 3/10ths, and then I have 30 hundredths, then I have 3 thousandths. It all stays the same, okay? It doesn't change the value of that number. It all stays the same. So in this case, when I change the value, the 0 does not change the value of the decimal. So when I add the 0 to the right of the number in a decimal, it doesn't change it. But in a whole number, it does, okay? Now, what happens if we insert a 0 to the left of a whole number? So I put a 0 to the left. I have 3 here. I still have 3. I still have 3. It didn't change at all, right? If I had 52, I still have 52. I still have 52. It looks different, but it didn't change the value of that number. But what happens if we insert a 0 to the left of a decimal number? Okay, so if I add a 0 here, instead of having 3/10ths, now I have 3 hundredths, and I have 3 thousandths. Or instead of having 52 hundredths, now I have 52 thousandths. And so it changes the value when we add that decimal to the left of our number, okay? All right, let's look at these. It says, do the pairs of numbers below have the same value? So think about what we just talked about, and then I want you to decide, does it have the same value or not? So if we look at these two numbers, I'm not going to say them because it kind of gives it away. But what do you think? Same value? Yes or no? Yes, they do. Because in this one, it's 6/10ths, And in this one, it's still 6/10. Even though I didn't add the 0 in front of it, it's the first number behind the decimal, and it's a 6, so they're the same. How about this one? Look at these. Yes or no? If you said yes, you are right on. In both cases, we have 25/100ths. How about here? Yep, same thing as well. Yes, it's the same number. Even though it has that 0 in front of it, it doesn't change it. It's the same number. All right, so we're going to use what we know now about adding zeros to help us solve some of these problems. So let's read this scenario. It says, Kathy had to compare some decimal numbers. She used what she knew about adding zeros to decimal fractions without changing their value. Discuss why her solution is correct. Says the problem, which of these numbers is the greatest? Now, just like we've done in the past and like what she did here, she lined them all up. Okay, so she wrote 0.35, 0.318, and 0.4. But I want you to see that she actually added extra zeros on. And just like we just discussed, when we add zeros to the right of a number in the decimal, it doesn't change its value at all, but it makes it easier for us to see the order, okay? So the question is, which one is greatest? And I can look at it and I say, oh, all the zeros are the same, but look, 4 is the greatest. And then I keep looking and see, okay, which one would be next? So I look and I see, okay, it's between these two. The 3's are the same. Then, oh, look, there's a 5. So this would be the second greatest, and then this one. And we're going to practice ordering decimals in just a few minutes here on their next, when we get down to number 15. But let's again practice comparing them. And again, a good way to practice comparing them is to write them over each other, and they're going to start getting more difficult. So let's go ahead and write these out. We have 0.36. I'm going to actually say it that way just for now. I have 36/100ths, and then I have 82/100ths. Again, I write them out, and I do my comparison. Okay, so my zeros are the same? Nope. And then I look at my tenths. Ooh, and look, 8 is definitely bigger than 3. So I know that 82/100ths is greater than 36/100ths. Okay, let's try number 8. Now, number 8 is one that I know people make a lot of mistakes on. So let's look really carefully at this one. I'm going to write this one out for you. And it's, see if I can fit it over here. 405 thousandths. And I'm going to compare it to 62/100ths. Now, again, a great strategy is to add a 0 at the end just to make it so that it's more clear, because remember, when we add a 0 to the end, it doesn't change the value. But sometimes it makes it easier to look at this and say, oh, 405 to 620, which one's bigger? Yeah, this one. Again, I cross my zeros. Look at my tenth spot, 4 and 6. 6 is definitely bigger. So, but here was the mistake that people make. They look at these two numbers and they say, well, 405, that's huge compared to 62, right? But remember, we're looking to the right side of the decimal. And so when we add that 0 on, it just helps us not have as many mistakes when we're doing those. All right, let's go ahead. And I'm going to have you go ahead and try on your own number 11. So you're going to compare these two decimals. And I want you to tell me which one is greater than the other. All right, so I'm going to write it out. I had 626 thousandths. And I have 65/100ths. Okay. So again, a good little trick is that when it doesn't align, like this one, I'm going to add a 0 just so I don't get confused. Okay, because again, it doesn't change the value because it's to the right of the decimal. All right, my zeros are the same. My 6's are the same, but, oh, 5 is definitely bigger. So now I know that 65/100ths is bigger than 626 thousandths. All right, let's try one last one. Why don't you go ahead on your own here and try number 4 or number 12. So I'm going to try that one. All right, so let's compare. I'm going to write them both out. Be real careful that you line your decimals up A mistake people also make is they don't line their decimals very carefully, and then they get confused. I'm going to line my decimals up. Then I'm going to add the zeros in just so I don't get confused. So I know that this is a 0, and I know I can add a 0 behind here without changing the value, and now I can compare. So first I'm going to start my ones column here. Oh, and look, there's a 1 and a 0. Which one's bigger? 1. So right off the bat, I know that 1 2/10 is bigger than 85/100. All right, now this is a great problem, and this is one that I see over and over again. So you really want to pay attention to this one. It says, the table shows the lengths of some common insects in inches. List the insects in order from largest to smallest. Now, we're really lucky because they lined all of these up for us, okay? The only thing I see is that I might need to add some zeros in here. All right, so I notice here that these go all the way up to the thousands, but this 8 only goes out to the tens. So I'm going to add 2 zeros, really little. Can you see those? All right. And I can add a 0 right here too, so that it goes out to the thousandths place as well. So now let's compare. So I'm going to look down here, all the zeros are the same. And I'm looking for the biggest first, the largest. So I got a 2, a 0, a 1, a 7, and an 8. Well, which one's bigger? You said the bumblebee? Right on. The bumblebee is definitely bigger. Okay? So then I'm going to go ahead and cross off that bumblebee so I don't get confused. I did the bumblebee. All right, now I'm going to go back and I'm still looking at those tenths. 2, 0, 1, 7. Which one's the next biggest? You said cricket? Good job. The cricket is the next biggest bug. All right. Then we keep going. 2, 0, 1. Well, 2 is bigger than 0 or 1, so the ladybug would be my next one. And then keep going. And between these two, we got a 0 and a 1. Well, the mosquito is going to be the next biggest, and then the aphid, because it's at 0 in the 10th spot. So you can see how when they're all lined up like that, it's really easy to put all those decimals in order. And you look at that originally thinking, oh, that's going to be really hard. But again, if you've lined them all up, it makes it a lot easier. All right? All right, the last two we're going to look at here. It says, circle the number in each group that does not have the same value as the other. So remember we talked about, when you add the 0 behind the decimal, it doesn't change its value. So let's look. We've got 7/10, 70/100, 7/10, and 7/100. All right. So now look at those. Which one is not the same? You said this one. You're correct, because look, it comes in the 100th spot. So if I was going to write this as a fraction, it would really be 7/100 instead of 7/10 like that other one there, right? All right, now go ahead and look at these numbers and see if you can figure out, that's a 4 right there, by the way. Which one do you think does not fit with the others? Which one is not the same number? All right, if you said 4 8/8, you were correct. Okay, because here we got 4 8/10, 4 80/100, 4 8/100, and 4 8/1000. Okay, this one, our 8 doesn't come until the 100th spot instead of coming in the 10th spot like it did in all the rest. All right, so today we compared decimals numbers to the thousands. Great work.